Alrighty. So we're doing the shell game. We're going to watch the water. You guys try and keep track. Okay? So we're starting with water right here. Okay. You guys ready? Here we go. We think this one, that one? This one? Ooh, we've got people saying different things, but most people are saying this. So let's test this one first. Oh, you guys are so smart. There it is. Okay, right there. Okay, ready? We're going to do it again. So where is it right now? In the middle. Okay, here we go.
You never moved it. It's in the middle.
In the middle? Oh, you guys seem so confident. Let's
Yes,
see.
I'm very confident.
Ah, you guys are too good. Anyone willing to make a bet on this last one? Bet your grade on
I
it?
will make a bet on it.
It's gonna disappear a bit more.
Ooh, we got some kids willing to make a bet.
I'm definitely willing to make a bet.
My 2 fingers in the middle.
Your 2 fingers?
Yeah.
You'll bet 2 fingers, so if you lose, I get to cut them off? Is that what you're saying?
Yeah.
That's fair, right?
I've lost 2 fingers.
Okay, just making sure. Which one?
That one.
Middle.
Most people are pointing this way, so you're saying this one?
Yes.
Let's do them one at a time. So who thinks this one? Nobody. Ready? Oh. This one. We have some people think
Nope.
this one. Ready? Oh.
Called it.
Most of us are saying this one. Okay. You got your notes open, right?
He cheated.
No, he picked them.
So on your notes, the first thing on your notes is what's called a phenomenon. So we're going to fill this out. Phenomenon. What is a phenomenon? I'm going to rotate this tiny bit. There we go. What's a phenomenon? Anybody know? Okay, shh. What's a phenomenon? Something that you can't explain. I like that. I'm actually going to word it as something you can't fully explain. Because maybe you know part of what's going on, right? So a phenomenon is something you can't fully explain. Okay? A phenomenon is something you can't fully explain. And a phenomenon is what introduces us into the scientific method. Okay? The scientific method is a way of learning, and it's a way of figuring out these things that we didn't already know. Okay? So in this case, what's the first, well, in this case, in our example, what is our phenomenon? The water disappearing. It's the case of the missing water. I'm going to write H2O because I'm lazy, and you guys should know that H2O is water, right? Okay. Now, what's our first step of the scientific method?
Asking questions.
Asking questions. You notice it's the first thing on the paper after phenomenon? Oh, you guys are clever. Okay, so we need to ask questions. Now, these questions need to be based on the phenomenon.
Why did the water disappear?
Okay? Okay? Right, that'd be an example, right? So it needs to be based on the phenomenon. So, in our case of the water disappearing, I wouldn't ask, what am I going to eat this weekend, right? Like, those aren't related. So in this case, what are some questions we can ask about this? What's that? Where did the water go? Okay. What made the water disappear? I like both of these, okay? I kind of like what made the water disappear a little bit better for this example, so we're going to go with that one. Okay, what made the water disappear? Okay? What's after a question? Next step in the scientific method. Yeah, the next step is to develop a hypothesis. Okay? What is a hypothesis?
It's what you think happened.
Yeah, what you think happened. Good. Any other thoughts? Okay, a agree. I like to list a hypothesis as an answer to our question but it's based on previous knowledge. Okay? An answer to our question, but based on previous knowledge. In this case, what is a hypothesis that can help answer this question? What made the water disappear?
I think it went into your beard.
I think it went into my beard. I'll tell you what, it does soak up a lot of water. Okay? Any other thoughts? Yes. I drank it. Oh, okay. Any
You
other
tucked it
thoughts?
behind you?
Dumped it behind me. Maybe the floor is wet. Okay. Everybody's like, is it? Okay. Lily's.
There's a piece of cotton in the last one.
Okay. It's a piece of cotton in it. So we've got a couple of things. We've got, I drank it. It's on the floor. Or there's something in the cup. Okay, good. What's the next step of our scientific method?
Design an experiment.
Design an experiment. Okay, what is an experiment? It's something you do to find an answer, okay. An experiment is a test. You're testing your hypothesis. Okay? How can we design an experiment here?
Look in the cup, on the floor, in your beard.
Okay, cup, floor, beard. All right, we can do that. Look in cup, floor, and beard. Okay? My beard has some beard bone in it, so it's a little oily, but there's no water. Sorry. I'm not gonna let somebody else come and like touch my face. You can see the floor. Then the last one is see the cup. So let's look. Okay. Cup number 1, cup number 2, cup number 3. What's our next step?
Analyze data.
What does it mean to analyze data?
See where you went wrong and where you.
Let's raise our hands, Ben, so we can have a chance for everybody to answer. Okay? How can we analyze data? What do you think? Ava?
Look at the data, how we found out, and maybe a hypothesis.
Maybe. So we definitely need to look at the data. Okay? We look at the data. We try and figure out what it is. In this case, analyze. What was our data? When we looked in the cups, did we see anything? No. So we saw nothing in the cup. Okay? Now, a lot of times your data is going to be things like numbers, right? You'll have graphs, you'll have charts, you'll have mean, median, mode, stuff like that, and you do need to analyze and look that over and things like that. Okay, before going to your next one, what's our next step? Conclusion. Okay? So next we have a conclusion. Okay? What is a conclusion? Yes.
How it ended.
Okay, how it ended. Okay, good. Any other thoughts, Annalise? Ending statement, okay? It's how we explain the data. Or I guess we should say results, right? Okay, so here we're analyzing the data, we look at it, we try and interpret it, and then here we're explaining it to others. How many of you have ever read or seen a graph and couldn't really tell what it was trying to tell you? Okay, yeah, most of us have done that before. Okay, in this part, in the conclusion, you're explaining what that graph was saying. okay? The analyzing data, you're showing the graph, the conclusion, you're explaining the graph, okay? Now, in this case, we didn't have a graph, we just saw nothing, so what's our conclusion? It's pretty simple. We saw nothing, okay? So we've not really solved our question of the missing water. So what do we do next?
Do it again.
That's right. A lot of times in science, you gotta go back. You get to the end of your experiment and you realize, I still don't know. So I need to try again. Sometimes you need to redesign your hypothesis. Sometimes you just need to tweak your experiment. Okay? In this case, what do we think? What should be our new hypothesis? New hypothesis. Ben?
The water evaporated.
Okay, evaporation. Ava?
Something absorbed water.
Okay, maybe there is still something in the cup. Okay, and we're just not seeing it right now. Okay, so we've got evaporation, or there's still something in the cup. Bless you. Okay, what's a new experiment? What can we do to test these? How can we test to see if it was evaporation? What do you think? You don't think it's hot enough to evaporate? It's a good prior knowledge to have, right? Ben?
We could test the humidity.
Test the humidity in the air, that's possible to see if the humidity increased whilst doing the game, right? Okay, what about the other one? How can we test if there's still something in the cup? Before we looked, are there other ways to learn things aside from just using our eyes? Abram? Yeah, you said yourself, right? Maybe we need to smell the cups. Okay, maybe we need to smell them. Ava? Yeah, maybe we need to feel inside the cups. Okay, anything else? No? I'm listening. Anything? Yeah.
Listen to cup.
Yeah, maybe we need to listen. Okay, if there's some sort of popping or crackling noise, that should tell us something, right? Okay, and then lastly, there's one other thing we could do.
What?
Yeah, we should be looking again, right? We're not blind, okay? And?
Tasting?
Taste. You can taste. Not always. You don't always want to do that. That's not always a good idea, but that is something you could do, right? Okay? It's actually something that happens in geology all the time. There's some rocks you identify them by licking them. Okay? I know. Yeah. Okay? So, let's run through this experiment. Do I have anyone who's willing to help demonstrate? Now, you've got to be on camera. You'll be on camera, and I'm going to put this on YouTube. So, like, your parents have to be, like, okay with it. I'm going to do Ben, because I do know your mom. So then if there is a concern, I've talked to her before. Okay? So, I want you to look, touch, smell, whatever you need to do. Ooh, he's found something. All right, thanks, Ben. Ben's found something.
It's not cotton.
He's found something. So now, we need to do a new analysis. Okay? Let's see what Ben found. Something. Ooh, you guys are already beginning to make conclusions. Let's make some analysis. Let's make some analysis with that, right? So I'm going to walk around. You can feel it if you want. It's non-toxic, okay? You don't have to touch it though, okay? But I'll move around. And while I do, you can do that. And then try and make lists in your mind of what properties this has. That's analyzing, okay? So if you want to touch it, you can. You don't have to. No, don't. I mean, it's not toxic. You think you know? That's good. Save it for the You're not very familiar with cottage cheese.
I am.
Oh, I know what it is.
Ooh, I'm glad you guys have ideas. awesome. I'm glad a lot of you guys have ideas.
Wait a minute.
Alrighty. So, we need to analyze our results a little bit, okay? So that means we're going to list the properties. What did we learn about this when we saw it, and we felt it, and things like that, okay? So let's list our data. What did we learn from our data? Ben?
It looked kind of like tiny flecks of gel.
Small gelatin in nature. I may have spelled gelatin wrong. Okay, any other thoughts? Yes. Okay, so that's a conclusion. We're still listing the data about it, what we saw about it.
It's kind of squishy.
Okay, squishy. Is it so squishy you want to die? Okay. It was white, right? White in color.
Very squishy.
Okay, it was cold. The touch. Okay, soft. Good. Okay, now we need a new conclusion. This is where you interpret this data and you share what you think it is. Ava, what do you think it is?
Gelatin is spelled with a D.
Is everything else right?
Yes. I as in A. Yeah.
Okay. Thanks, guys. Okay. So, conclusion. What do we think it is? Let's hear your theories. Yes.
I think it's the stuff that like is in babies' diapers when you put them open. It's the stuff that absorbs water and stuff.
Okay. It's something in a baby's diaper, so you mean like pee, right?
No, like the
I'm kidding.
stuff inside.
I'm joking. I'm joking. Okay, what else could it be?
Instant snow.
Instant snow. Okay, instant snow. You can buy that at Hobby Lobby, right? Did you guys know they have a science section of Hobby Lobby?
Really?
Yeah.
Wow.
Yeah, that's where, whenever my wife drags me there, that's where I go. And I just sit in that part and look at things.
Your wife drags you to Hobby Lobby.
Yep. Okay, any other ideas what it could be? Okay, now that we've drawn a conclusion, what's our last step?
Seeing what it actually is.
No, on your paper, it's the last thing.
Communicating results.
That's right. We need to communicate those results. Okay? So, in other words, you share what you learned. Now, this is very important in science because a lot of times you'll have information, you share that information out to the scientific community, and they'll have things to add to or to take away, okay, before you can actually know that you've gained new information. Does that make sense? Okay, any questions about all of this? I'm going to move out of the way again, maybe zoom in for a second for anyone who would be doing this later. I can't zoom in. Never mind.